Okay, moving on. We are up to the disjunction rules. So, likewise, from the Forbes book, if you flip to the back of the front cover, you'll find the rules. Here we're going to go through OR elimination and OR introduction. So, for the disjunction, it's a crazy amount of lines that are required, and so a lot of students get confused as to what's going on there. So I'll probably go through this a little faster than usual, and then it's probably a better idea to explain it once we do an actual problem. So the rule of OR elimination is pretty complex. It's going to involve two assumptions that are going to be directed by the disjunction that you have to work with, whether it be derived already or from a premise. So here you'll see that it's blank. So whenever you have a disjunction and you want to use one of its disjuncts, or you think one of its disjuncts is going to be useful in your proof, you're going to have to assume both of them to try to see if you can get to the same formula from both directions. So the formula that is sort of the example here is R. So to start off with, you have to have a disjunction, right? And then you assume the left-hand side, and usually goes first. It doesn't really matter. But once you assume the first disjunct, right, you then derive whatever formula you want to get to. Call that R. Once you get to your formula, right, you're going to assume the other side of the disjunction, right? That's going to be Q, assumed. And then from Q, you should try to derive R as well. Right here, once you've derived R from both sides, from both P or Q, you can then repeat R, right? Repeat the same formula that you got from both sides. And then you're going to use the rule of OR elimination to discharge both of these assumptions at the same time. So this is the third discharging rule, and it's the most complex. But the sort of letters work like this. So it's five references to the line numbers, right? The first is the disjunction. The second is the assumption of the first disjunct, sorry. The third is the target formula, right? The fourth is the second assumption of the second disjunct, and then the second time that you've arrived at the same target formula. Remember that these two formulas must be the same. And so what I mean by a target formula is just anything that can be derived from both sides. If you can derive a formula from P, right, and then you can do the same formula, you can get to the same formula from Q, that is a target formula. So you can then repeat that and use this rule to eliminate or discharge both assumptions. So we'll see that happen in a little bit. For the rule of OR introduction, what's going to happen is you'll get to create a disjunction. So OR introduction, just like a lot of the other introductions, create the formula for which it's named. So disjunction introduction creates a disjunction. Conjunction introduction creates a conjunction. Conditional introduction creates a conditional. And negation introduction creates a negation. So it matches up nicely like that, although sometimes some of the other names of rules don't match up. But at any rate, here from any formula that you've either got as a premise or derived, call that P, at line J, you can from there infer whatever disjunction you'd like. You can infer P or Q or P. Right? So you can go on either side of the disjunction. This is pretty useful to create a larger formula from single atomic sentences or more complex compound formulas. at any rate, we'll see this in action, and I'll explain it a little bit more in detail. So the sequence that we're going to do is not A and not B entails not A or B. So we have one premise. So here, as you can see, you have a conjunction to work with. Those are pretty easy to work with because the rule of conjunction elimination allows you to pull out either conjunct. You can do so right now, or you can wait. Usually, I like to make my assumptions in the beginning and then work from there. So as you can see, we're trying to go from a conjunction to a disjunction. Which means we can't pull it out of the premises. I'm sorry, we're going from a conjunction to a negated disjunction. So here, to create a negation, remember, we can use negation introduction. So negation introduction is the one that makes negations. So to make a negation, we're going to use it, right? And we're going to apply that to this formula in order to create a negation of that formula. So the formula we want to negate is A or B, right? And so we assume that, right, in order to use negation introduction. And likewise, as soon as you assume the opposite of what you want, it's part of the reductio ad absurdum method. And also that once you do the reductio ad absurdum method, you assume the opposite, and then you're going to try to look for a contradiction. And so this is what we're going to try to do after we make this assumption. This is the only assumption we'll need, and so we can move on from there. Right. So here, we can start to pull out from the premise that we have. So I'm gonna take A. So that's from 1 and elimination. Right. Now we're trying to look for a contradiction, right? And so if you see that, look, if I had A by itself, it would create a contradiction, right? But we don't know if A is true. It could be that A is false and B is the one that's true. So because this is a disjunction, we're not sure. So let's assume that A is true, and like the rule says, we're going to let our disjunction direct us on what to assume. So I want to use A to try to get my contradiction. And so I'm going to assume that, right, to see if I can use or elimination. And if I can get a contradiction again from the other side, from B, then my contradiction can be a target formula. So we assume A. Assumptions have the same dependency numbers as their line number. Right? And then clearly we have a contradiction, right? And so we can write the lambda, and that's from 3 and 4. Negation elimination. Right? So 3 is 1 and 4 is 4, so that's 1 and 4. Right? And so we got a contradiction from that. And so we can't really use this contradiction, or rather you could use the contradiction and go on to negate your assumption and then get your conclusion, but you'll see that if you negate 2, right, that means that 2 will be discharged, but 4 will not. And so the number 4, the assumption on 4, will remain in your dependency numbers until you discharge it with this rule. So that's why I'm thinking I'm going to try to get a contradiction again from B. It'll save me some lines. Okay, so we assume B, and we're going to try to discharge it with or elimination. Right? And so to produce a contradiction, we're going to need not B, which we straightforwardly have, and it's over there. So we can pull that down from 1, and elimination. Yeah, that's an and. Okay. All right. So there we have another contradiction. And it's from 6 and 7, negation, elimination. Right, so that's 1 and 6. So line 9, what we have is a contradiction that comes from the assumption on A, and a contradiction that comes from the assumption on B. So if A was true, we'd get a contradiction. But if A was false and it was actually B that was true, we could still get a contradiction. So we don't actually need to assume A or B, right? Because they both can't be false. If they were both false, of course, this disjunction would be false. So one of them must be true. So from this disjunction, a contradiction would be true. So we want to be able to signal that, right, with our reference numbers. So from, oh, I'm sorry, that should be 2, right? From the original disjunction, right? We assumed the disjunct on 4, and we've derived one of our contradictions on 5. Then we assumed B, the other disjunct, I'm sorry, on 2. And then we derived, again, a contradiction. And so we're going to use the rule of OR elimination to say that we can get this contradiction just from the original disjunction, which is, of course, an assumption, but that's okay. So to calculate the dependency numbers for this line, you'd have to get it from all 5 lines. So it should be from 2, 4, 5, 6, and 8. Right? And so 2 is 2, and 4 is 4, 5 is 1 and 4, 6 is 6, and 8 is 1 and 6. However, like this rather complex schematic version of the rule says, here we put together the dependency numbers from the disjunction, the dependency numbers from the target formula from P, and the target formula that's gotten from Q, but we leave out the assumption from P and Q. So here we leave out the assumption from 4 and 6. And so what happens is we actually just get 1 and 2. They're a little over there because I miscalculated. Anyways, the 10th line, after we get our contradiction, right, we then can negate one of our assumptions. And the assumption that we're trying to negate is, of course, the second line. So here, we're going to negate A or B, right? And once we make that negation, of course, that's our conclusion. So here, line 2 and line 9, by applying negation introduction, produces the formula not A or B. Okay, and then the dependency number is from 2 and 9, but because this is a discharging rule, again, once we use this rule once we use this formula, this line with this rule, we discharge the assumption. So only 1 should be in our dependency numbers. So I'm going to try to sort of visually draw out what these lines refer to. So 2, right, as you can see, refers back to our, that might not show up. I use red. So 2 refers back to the original disjunction, right? 4 refers to the first assumption, right? 5 refers to what you got from the assumption of A, right? And we got the contradiction. 6 refers to the second assumption, which of course is part of our disjunction. And then 8 refers to formula that is the same. So the target formula, like I said, has to be the same, right? And so the target formula here is the same as that here. And so that means that from both directions you can get this formula, right, from the disjunction. Because we don't know that A is true for sure, nor do we know that B is true for sure. But we know that the disjunction is true, so one of them must be true. So in case that one is true and the other false, we can still get to the contradiction. Okay, I hope that was clear. Yep, I'll move on to the next rules.